We have 60, probably 60. We have 60 on the pass. The first one is that. It's probably start now. It's the only class. Take some of the pain off. It's like only other classes.
Oh.
No, it's not.
Okay, are y'all ready? What?
Yeah, it's still pretty. I
mean, that might be.
There we go. Okay, so guess what? You only have one question for homework today. Just one question. Okay, so we're building on vectors from last time. And today really shouldn't be very hard as long as you kind of understood last time's lesson. So do you remember last time how we multiplied vectors? And then if you times it by 5, would it get longer or shorter? By 5. Longer. What about if you times it by half? Shorter. Okay, so today we're gonna add vectors. So if you look up here at the top, okay, vectors can only be added with other vectors. And the way that you add vectors is you're gonna add the horizontal components together, so the x's, and then you're gonna add the y's together. Okay, you cannot add a vector with just a regular scalar. Okay, you cannot add a vector with just a scalar. They can only add with other vectors because you need to have an x and a y for them to add with. So take a look at the first example. If I wanted to add these two vectors, I'm going to add the two x's together. What numbers am I talking about? What's 6 plus 2?
8.
Then your new x is an 8. Very good. Okay, look at your second coordinate or your vertical component. I'm adding the y's together. What are my y's?
1 negative.
What's 1 plus -5? -4. Boom, you did it. Okay, take a look at the second example. When you add vectors, you put the x's together, then put the y's together. For the x's, which numbers am I talking about? -2 and 4, add those together, what do you get? Okay, 2. And then for my second digit, it's a 5 and a 0. What's 5 plus 0? 5. Okay, do we know how to add vectors?
Yeah.
Okay, the second thing that you should be able to do is draw a vector diagram of addition. Now, we did this. Gentlemen, are we ready? Okay, if it's multiplication, do you remember how this was your original vector and then you times it and it got longer? Okay, that's a vector diagram. So all that we're talking about is you should be able to do it algebraically just with the numbers. And then you should also be able to do it as a picture. So let me show you what that looks like. It's very easy. When you add vectors, you should sketch them head to tail. And then if you forgot which one's which, the tail is the dot end and the head is the arrow end. Okay, the tail is the dot end and the head is the arrow end. So basically what you're going to do is just connect them in a row. So for example, if I wanted to add 3 vectors, I would sketch my first vector and then start the next vector right after. So let me show you what I mean right here. graph vector 6, 1. So pick any starting point that you want. I'm gonna let my 6, 1 starting point be right here. Okay, but remember, it doesn't matter where you started. And then if my vector is 6, 1, I'm gonna go 6 to the right, 1, 2, 3, 4, 5, 6, and up 1. Then if I want to add 2, -5 to that, I'm gonna pick up right where I left off and just stack it onto the end. So my red vector is gonna start right here. And then I'm gonna go 1, 2, 1, 2, 3, 4, 5. Okay, that's what vector addition looks like. Okay. Then from there, your resultant vector, which is just like the answer basically, okay, is going to connect the original tail to the final vector's head. So what that means is your original starting point connected to your final end point, that vector is your answer. Now, remember, we already worked this question out algebraically. Do you remember the answer we got when we added these two? What did we get? 8, -4. So my new vector should be 8, -4. Let's check and see if it is. When I count over, it's 1, 2, 3, 4, 5, 6, 7, 8. Then down 1, 2, 3, 4. Did I still get 8, -4?
Yeah.
Yes. So graphing and algebraically, your answer should be the same. The only difference is how you're getting it. Okay, one more like that. Take a look at B. We're gonna start with -2, 5. Pick a starting point. Doesn't matter where. And then you're gonna go to the left 2, up 5. Okay, that's your first vector. Okay, Alex, can you stop? And then 4, 0 is my second vector, but if I'm adding them, I have to add them head to tail, which means I'm gonna start right here on top of the old vector, and then I'll graph my 4, 0. 4, 0, I'm gonna go 4 to the right, 1, 2, 3, 4, up or down 0 means that it's pointed straight to the side. Your resultant vector or answer is gonna connect the original starting point to the final end of that vector. So it's gonna be here to here. Okay, that's your resultant vector. And result or resultant vector just means that's like your answer when you have the two. So now let's count the components of that and make sure we get the same answer we did when we did it first. So I count to the right 2, up 1, 2, 3, 4, 5. And is 2, 5 what we originally got? Yes. Okay, questions on that? All right, go ahead and turn the page. Okay, so last class, if you had the vector, you could find the magnitude. Okay, and I have the steps up here on the board from when we did the homework. Okay, but you can find the magnitude. That's the a squared plus b squared and then square root, and you can find the direction. Okay, so today we're gonna go in reverse, that if you know the magnitude and you know the vector, you can write it as an xy. So you're gonna use this formula up here at the top. Oh, you missed it. Okay, the double bars, that's the magnitude. Okay, that's the magnitude, and remember that the magnitude is how long the vector is. Okay, guys, you can do it. Okay, so take a look at number 1. Let me show you how to do it. Okay, it says vector V has a length of 8 and a direction of 130. So all that you're gonna do is take those numbers and put them into this formula. So which number is my length? The 8 or the 130? Which one is the length? 8. So then I'm gonna put vector v equals 8 cosine something, 8 sine something. And then theta, what I'm gonna put in the cosine and the sine is gonna be the direction. And they gave us the direction. What did they say for vector v? How many degrees? 130. So my vector is gonna be 8 cosine 30 and 8 sine 130. Now, quick question, where else was your x value a cosine and your y value was a sine? What else did we just recently cover where cosine was the x and sine was the y? The unit circle. So this is basically still that, okay? So in your calculator, I want you to turn those into numbers. So we're gonna find 8 cosine 130 first. That comes out to negative 5.1. And then my second vector is 8 sine 130, which is 6.1. Okay, now let's do the second vector, which is gonna be W. So first thing we're gonna do is put the length in the front. So it tells me that for vector W, my length is how far? 15. So I'm gonna do W equals 15 cosine something and 15 sine something. Remember, cosine's still in the x, sine is still in the y. And then my direction is given to us that is how far? 265. So then if you will, please put both of those into your calculator. We're gonna just do one decimal place pretty much all day to keep it the same. So I'm gonna find 15 cosine 265 and 15 sine 265. So W equals negative 1.3 comma negative 14.9. So now we have both vectors. And then in the next step, you're asked to add them. Okay, but we just learned how to add them. How do I add vector V and vector W? We just learned how to do it. How do we add them? What numbers do we add with each other? The x's are gonna go together, that'll be the new x, and then the y's, add them together, that'll be the new y. So V plus W is gonna be negative 5.1 plus, and then negative 1.3. So remember, you're adding x with x, that'll be your new x value. So it came out to negative 6.4. And then can one of y'all add up both of the y's, please? So we do 6.1 added with negative 14.9. So what would we get for that second digit? Okay, negative 8.8 is correct. Okay. From there, it says to sketch a vector diagram, okay, showing that addition. So let's do it. We're gonna start with vector V. Keep in mind, this is a very basic sketch. Okay, so you don't have to like measure anything really. So vector V is negative 5-ish, comma 6. So watch what I'm gonna do. I'm gonna go to the left 5 and up 6. So we'll go left 5, up 6, we'll say it's here. That's vector V. Just a sketch though. Next, I want to add vector W, and W is a negative 1, comma negative 15-ish. So start at the end of your first vector. You're gonna go to the left 1 and then down like 15. We'll say it's maybe way down. That would be vector W. So V is the original. We added W onto the end. then the answer vector should connect the original tail to the new head. So it would be right here, from here to here. Now, quick question, look at your picture and look at your vector. Does the black vector match -6, -8? Is it to the left 6 and then down 8 maybe? Does that make sense? Okay, yes, that should always match. That this arrow, your resultant vector, we're gonna call it R for resultant, should always match what your coordinates were when you had. Okay, from there, it's review of what we did last time. You should be able to find the magnitude, which is how long it is. And then you should be able to find the direction. Let's review how to do that. For magnitude, you're gonna do a squared plus b squared, then take the square root. Do I care that my x and my y up here are negative? No, because when you square it, it's gonna drop off anyways. So it'll be 6.4 squared plus 8.8 squared, and then square root that. Okay, that is how you find the magnitude in your calculator. And remember, magnitude is the length of the vector. So I'm gonna do a squared plus b squared. I get the square root of 118, and then for today, we're gonna actually find how long it is. We're not gonna leave it as a radical. So what is the square root of 118.4? Very good. Okay, 10.9. All right, then last part of this, you need to know how to find the direction. You have your direction right here as number 5. Okay, we're gonna do inverse tan on y over x. So remember that tan equals y over x, which in this case means that my tangent equals -8.8 over 6.4. But then remember that for tan and for magnitude, you don't really care about the negatives. So I'm gonna leave them off. Then to solve, to get rid of the tan, I have to inverse tan, which is the tan -1 that you see on the board. So then these guys cross out and you'll know what theta equals. So go ahead and put that in your calculator. We're gonna round degrees to the nearest whole number. So we're doing second tan on 8.8 over 6.4. Very good. So 53.9, we're gonna round that to 54. Now, here's the problem with that. Let's review what we talked about last class. When you do your 54 degrees, look at my picture real quick. That is measuring how many degrees are on the inside of this triangle that I'm highlighting in green. Okay, but remember that that's not where direction has to be measured from. Do you remember that direction has to be measured from all the way over here? So if I want to go from here all the way around the circle to where my black vector is pointing, what quadrant would I be in if I want to go here? Third. And if you look right there, I kept the formulas up there. But remember, it's 180 to get to here, plus 54 more. What is my actual direction? 234. So I'm going to put quadrant 3 is 180 plus theta, which means that my direction is going to be theta equals 234. Okay. Then also keep in mind that that first theta that you find has a name. That's called the reference angle. Okay, so if you see that, remember you have to find the reference angle first to then be able to use your chart for direction. Okay, does that make sense? Okay, we have to add one more new thing, but it's kind of a little thing. So turn the page. Okay, Henry, can you put that away? You haven't taken a single ounce of notes. Ooh. and Colin. You have? Questionable? Sus? The first page? Alright, we'll be done with notes soon. Can you put your computers there, please? Alright, last page. Or last new thing with vectors. Okay, the problem is that for math, okay, standard form, you always start from here and you rotate this way. Okay, but as far as the way maps work, no one does that. So we have north, south, east, west. Those are called cardinal directions. So all that we have to do is transfer from one to the other, but it's not too hard. Okay, pretend that your compass is a unit circle. Which direction would you start from? East. So label east as 0 degrees. That is your starting position always. How many degrees would 90 be at? Which direction? North is 90. What about west? If I go halfway around the compass, 180. Now let's put in our Habsy points. Okay, if I'm exactly between north and east, I would call that northeast. And what would be perfectly between 0 and 90? 45. Very good. Okay, what if I was perfectly between 90 and 180? 135. And what would I call that as a cardinal direction? Northwest. Very good. Okay, across the bottom, it's 90 to get to the top, 90 to the side, another 90 to get to the bottom. What is south? 270. And then what would perfectly southwest be? 225. Which means that perfectly southeast would be what? 315. Okay, and you should notice that all of those perfect cardinal directions are already on your circle. Okay, however, sometimes your direction's not a perfect diagonal or up or down. So take a look at the examples there. We'll go through each one. If I want to be northwest, what is that in degrees? This one's already on your thing. 135. Northwest is a perfect diagonal. 135. But if I want south 10 degrees west, here's what you're going to do. Okay, you're going to start off pointed south. So south would be here. In purple, south is here. And then I want to tilt 10 degrees towards the west. So if this is south, I want to rotate 10 degrees this way so that this is my new direction. Here's the question. If I have to measure from here all the way around to here, do I add 10 degrees to 270 or minus 10 degrees from 270? Minus, because I'm going from 270 a little bit backwards. You're unwinding 10 degrees. So what direction would that be in degrees? 260. Okay, let's try the next one. I want north 20 degrees east. So you're going to start off pointing perfectly north. How many degrees is that? 90. And I want to tilt 20 degrees to the east side, which is which way, left or right? It would be to the right, 20 degrees. So should I add the 20 degrees to 90 or should I subtract them? Because my start, I'm not even going to make it to 90. I'm going to take 20 degrees off. So how many degrees would that be? 70. Okay, one more left. Give that one a shot. South 25 east. South 25 east. Would I add 25 or subtract it? Add. So if I'm south and I tilt towards the east, I'm rotating further than what number here? So 270 plus 25, what would my new degree be? 295. Okay, you can do it? All right, so now let's work one word problem all the way through and see if it makes sense. take a look at number 2. Okay, we have a boat traveling at a speed in still water of 20 miles per hour. That's your magnitude. Okay, then it says at a direction of perfectly southeast. Let's write the coordinates of the vector. So I'm going to put B for boat equals. Your magnitude goes in both parts. So it'll be 20 cosine something, 20 sine something. And then in the blanks, you're going to put the direction, which is perfectly southeast. What is perfectly southeast in degrees? Look on your compass. 315. Okay, then from there, you're going to turn that into a component vector with your calculator. So will you type in the X and the Y so that we can know what those values are? So find 20 cosine 315 and 20 sine 315. So we got 14.1 positive and then negative 14.1. Okay, but your boat isn't floating through nothing, it's floating through the water, and it says there's a current. So now let's read about the current. Okay, it says the current is going 11 miles per hour, that's the magnitude, and it's going north 30 degrees east. So I'm going to put the 11 degrees or 11 miles per hour in both. So we'll do current equals 11 cosine something, 11 sine something. And then in the degrees, I'm going to have to convert the north 30 degrees east into something that I can use. So think about that for a second. What is perfectly north? 90. And if I want to tilt 30 degrees east, should I add the 90 or subtract it? I should subtract it. So if I'm perfectly 90 and I go 30 degrees this way, what would that leave me at? 60. Okay, then turn that into a component vector. So C equals, you're going to type in both parts separately. 11 cosine 60 and 11 sine 60. So go ahead and type those in. And then once you find them, you're going to add the two vectors together. Remember, we add the x's and then add the y's. Can you type them? Can I type them? You have yours? All right, so find 11 cosine 60 and 11 sine 60. We do calculator over here. Too. Come out this.
So I'll talk about that.
Oh.
Bad habits of Joyner.
Uh-oh.
I gotta change them.
Uh-oh. What did you do? Give up weed or something?
Right on. Right on.
Is that it? That is hard. Uh-huh.
It's like all day.
Oh, there's a bunch of water here. Do y'all know this? Is it your cup? Oh, your cup is spilling. No, it's okay. Okay, I put my notes away. What'd you get for your C? Can you tell me the numbers? Okay, hold on. What was the X? 5.5, and then what's the Y? Perfect. Okay, so from here, we're gonna add them together because the boat can only go if we consider the current. Okay. So add this and this. Tell me that number. What's 14.1 plus 5.5? 19.6 is correct. Okay, and then for the second digit, I have a negative 14.1 plus a 9.5. What's that result going to be? Negative 4.6, you said? Okay, very good. So when you add them, you're adding them because those forces are working against each other. Okay, Velocity has to be a vector because it has a magnitude and a direction. Okay, so next thing we're gonna do is sketch the vector diagram. Remember, this is a very loose sketch just to kind of check your work a little bit. So if I graph the boat, pick a starting point. 14.1 comma negative 14.1, I'm gonna go forward and down. I should be somewhere over here. That's the boat. Okay, next we're gonna do our current. 5.5 comma 9.5. So for my current, I'm gonna go over 5 and up 9. We'll pretend that it's right here. Then my resultant vector ought to come out to 19 comma negative 4. So if you look at your picture, when I connect from here to here, does that look like it could be over 19 and then down 4?
Yeah.
Sure. Okay, we'll put a little check. That's your resultant vector, so we're gonna call it R. Okay, so this is your answer right here. After you draw your diagram, you're gonna find the same two things you just found, the magnitude and then the direction. Okay, magnitude will be called speed, because if you remember, if you took physics, speed is just the length because it has magnitude, but it does not have a direction. So, not direction. So speed is literally just how long it is. You don't care which way the arrow is pointing. It's just how long the vector is. So we'll do 19.6 squared plus 4.6 squared and then square root. Then when you get to part G and you're doing direction, you're doing the tan thing. So it'll be tan theta equals y over x. Okay, so figure those two out. Ask me if you need help. Yes. I have some actually. You can clean it up after if you want. Oh, that's fine. All right, so we're turning our calculator on. Yeah. See what that is. Remember, no negatives in your Pythagorean theorem. All right, so we need to get to the next one. Not quite that far, but. And make sure this needs to be inverted in. Yeah. So it should have the negative 1 on it. Huh? Yeah. I'm listening. I have one more question. It's 13, but then you need to think about which quadrant. Oh, right. Henry, did you need this? All right, let's check our magnitude. What'd you get? What did we get for that? Square root it, yeah. Yeah. All right, so what did we get for our length here? Should be like 20.1 or something. Okay, 20.1. Now remember. Okay, remember that we said that the length is the miles per hour. So question, if your boat is only going 20, how is it really going 20.1? Because what else is pushing the boat? With the current. So the current, because it's also kind of east, it's like making your boat go faster. Okay, last little part of this. Did you do inverse tan on both sides? Did y'all do inverse tan on both sides? How many degrees did you get? Okay, 13 degrees is your reference angle. Reference angle. That's not your final answer. You need to consider what quadrant your black vector is in. What quadrant is your black vector in? 4, which means what of those am I using? 360 minus. So if I do 360 minus 13 degrees, how many do we get? 347. So the boat's actual path would be down 347 for your direction, and it would be going 20.1 miles per hour. Yes?
Yep.
Okay, all right. One more, start number 3, see if you can do it. Okay, you have a boat this time, traveling in a current. I didn't heard my squeaking and I was like, I knew something. No, this one's good. And you one color. But it's not the goal.
Oh, that was all you on your desk. It's so funny. Man, I mean, almost make no sense.
But it's so much, even if you write it, scribble it down.
Thank you, I appreciate that. I accept your apology. I accept it. When we're done. This is the last one we're gonna do.
Oh, it is?
So, and then you have one question for.
One question.
But it has like, you know. like- No.
That's not a great hour.
That's not mine. Oh, that's last time. Oh, you were gone. Do you need the notes to go with that? The paper? Okay, we cannot go on to your one homework question until you do your last notes question. So, let's see if we can write the vectors. You can do it. So for the boat, how fast is it going?
Someone
50 miles per hour.
Thank you, that is correct. So your boat should be 50 cosine something, comma 50 sine something. Okay, 245, because if it's south 25 west, perfectly south is 270. And then if I want to tilt west, am I adding or subtracting the 25 degrees?
Subtracting.
Subtracting. So we said that it was, what was it, 245? Okay, then in a minute, I'm gonna have you turn those into decimals. Now let's do the riptide. I put C for current, but you can change it if you want. Okay, the riptide is 32 miles per hour. So it's 32 cosine something, 32 sine something. And then if I'm south 45 east, perfectly south is 270. And tilting towards the east means I would add or subtract the 45. To go east, you would add it, so it would come out to 350. Okay, take both of those vectors and turn them into numbers. So you'll type in the X and the Y separately. We're gonna continue to round to the 10th place. Okay, raise your hand if you need help with that. And then in part D, you're gonna add them up. So everyone's calculator should be on, not darkened, because you haven't used it all class period. Yes? Yeah, this is the formula, so it's always the length in front, cosine, and then sine. Yes, that's right. And then you'll do 50 sine 245 to find the y. All right, we know what we're doing over here.
Yeah.
Very good. Let's get your vector diagram. How are we doing over here? Find your numbers. Okay. And then you're gonna add them together. X with X and Y with Y.
That's right.
I think so. I'm copying off of you, it was negative 21, 21. What's the decimal after 45? By what? Okay. Y'all got both of these the same,
Yeah.
and then what was y'all's current? Do you have that?
22.6.
And-
Be sure who spreads information.
Okay, when you type them in, you should get an X and a Y. Okay, so we're typing in this, boo, pause. What are you watching? Oh.
About that,
Oh, I know, because I got knocked up right when that movie came out. Oh, I cried. Oh, when I got pregnant with Ashton, that movie came out like a month later. I was like, it's so sad. It's like my actual life. And he was like pothead too. It was terrible. You're watching my actual life story. It's knocked up, where the girl gets pregnant with a pothead and she like had her whole life ahead of her. But now my baby's in high school. Alright, so we're typing this in. No, it's wonderful. It's not for a minute. Yes. So you're gonna put it here. So the velocity is gonna be the boat considering the current is where you have. All right, so once you have your boat and your current separately, to find the boat considering the current, you're gonna add them together because velocity is a vector. So what would negative 21.1 be if I add 22.6 to it? 1.5 is correct. And then what about negative 45 plus negative 22.6? 7.9, okay, very good. Then from there, the hardest part it seems like people are having is with the vector diagram. So we want to start off with the boat. Negative 21, negative 45. So I'm gonna go to the left 21, down about 45. Your vector should be down more than it is to the left. That's your boat. Then the current should be to the right 22 and down 22 because it's a positive X and a negative Y. So my next vector should go to the right 22 and down 22. That would put it maybe here. Doesn't have to look perfect. That's my current. So then my resultant vector should connect the original starting point to the new ending point. That's your R. And then I want you to look at your picture and see if it makes sense with this vector. Does it look like it goes to the right 1 and then down 67? Sure. Okay, also take note of what quadrant is that in for later. So I'm going to write down here, I'm going to be in quadrant 4, just so that I don't forget. Okay, then from there, you're going to find the speed, which is how long that vector is. A squared plus B squared, take the square root. And then you'll do tangent for your direction. So square root 1.5 squared plus 67.9 squared. That's your magnitude. Tell me how fast the boat is going. It should be somewhere kind of around 50. What are we getting for that? I gave my calculator away also. What is it? 67.9.4. Okay, and now think about, in this case, if the boat's only working for 50 miles per hour, then in this case, again, the current is helping it. Okay, then last part for direction, you're gonna do inverse tan on y over x. So 67.9 over 1.5. That'll give you your reference angle. So what is our inverse tan of y over x? How much? 89 is right. Okay, but then remember, 89 degrees is the amount of degrees in the triangle that's not your direction. So if I come back up to my vector here, if this is my triangle, right here, 89 degrees is this part. But remember, I can't measure direction like that. I have to go the long way around. So what is my formula for quadrant 4? 360 minus theta. Which means I do 360 minus 89, what would my final direction be? 270. Okay, do you get it? Okay. All right, your homework is that your table, you're gonna pick one of the last 2 questions and do it. So in the other class, I rolled a dice, and if they got odds, they did the odd problem, evens did the even, but I don't care, just pick one. And then you just have to do one and then show it to me and then I'll check you off. Okay? And you have no delta math today. No delta math today.